With around 146 moons, Saturn has the greatest number of confirmed moons in the solar system. Then after Saturn comes Jupiter with 95 confirmed moons, then Uranus with 28, and then Neptune with 16. However, the number of confirmed moons around Saturn and other non-terrestrial planets changed quite a bit over time as more moons were getting discovered around these big planets. In fact, they are still being discovered in recent times, that is in the 21st century. Most of Saturn's moons were discovered in the 21st century. Still, it's important to note that the moons that are being discovered around these planets in recent times usually have a diameter that is just a few kilometers. Out of the huge number of moons that were found around Saturn, 7 of them are major, that is, round moons. And even out of those 7, 3 go largely unnoticed as they are not as unique compared to the other 4. Those 3 are Tethys, Dione, and Rhea. However, most other non-major moons of Saturn are even more obscure. Currently, the most distant moon of Saturn is S2004 S52. Although this obscure moon was discovered in 2004, the discovery was announced in 2023. This moon orbits Saturn typically at a distance of 26 million kilometers. For some perspective, the moon is about 385,000 kilometers away from Earth. So the orbital distance of the most distant known moon of Saturn is much more comparable to the closest distance between Venus and Earth, and that is a distance of about 38 million kilometers. Now the orbit of S2004 S52 is also not circular, it is quite elongated. Because of that, this moon can get as far away from Saturn as 33 million kilometers, and at its closest, it is about 18 million kilometers away. This moon needs 4.4 years to complete a full orbit around Saturn. That is also somewhat more than double the time Mars needs to complete a full orbit around the Sun. Despite the immense orbital distance from this moon, Saturn would still appear to be huge. Typically, Saturn, together with its most visible rings, would appear to be about as large as the moon is from Earth. This puts into perspective as to just how large Saturn is. This moon has a very inclined orbit. That means that relative to the equator of Saturn, its orbit is tilted. On top of that, the orbit of this moon goes in the opposite direction from the direction in which Saturn rotates around itself. This is called a retrograde orbit. Also, its orbit is, as mentioned, very elongated. The inclined, elongated, and retrograde orbit together suggest that this is a captured object, meaning that it didn't form around Saturn from its protoplanetary disk in the distant past, but rather at a place much further away. Then it likely wandered into the orbit around Saturn. These orbital characteristics are typical for other irregular, that is, captured moons as well. Saturn's regular, that is, typically non-captured moons, have very different orbital characteristics. First of all, nearly all of them have an orbit which goes around the equator of Saturn, so their orbits are not heavily inclined. Second, all of them have very circular orbits. And third, the regular moons all have prograde orbits, which means that they orbit in the same direction in which Saturn rotates around itself. These 3 orbital characteristics together suggest that Saturn's regular moons formed out of a protoplanetary disk that was once around Saturn. Saturn also has 2 other moons which, like S2004 S52, also have an average distance of around 26 million kilometers away from Saturn, although on average just slightly closer. However, the distance most distant moons of Saturn have to Saturn isn't the most impressive one for the category of moons. That currently goes to Neptune's moon called S2021 N1. This moon typically has an orbital distance to Neptune of 50 million kilometers. However, its orbit is very elongated, and because of that, at its most distant point, it is close to 75 million kilometers away from Neptune. That is slightly further away than the distance of the most distant point of Mercury from the Sun. Also, this moon needs about 27 years to complete a full orbit around Neptune. So Saturn's most distant known moon doesn't look as impressive when compared to Neptune's most distant known moon. But still, there are other moons of Saturn which are even more obscure, and some that are potentially even more interesting. Iapetus is Saturn's most distant, regular and major moon. It is pretty well known. Iapetus orbits Saturn at a distance of 3.5 million kilometers. Despite Iapetus being a regular moon of Saturn, its orbit is weird in that it is quite a bit more inclined compared to the rest of major regular moons. However, considering that its orbit is prograde, and that it is also close to being circular, and also the similar composition to other major moons, those three facts together point towards the idea that Iapetus formed around Saturn from its disk some 4.5 billion years ago. But then after it formed, something tilted its orbit. What caused the orbit to be so inclined is currently not known. Beyond Iapetus is where the majority of Saturn's known moons are located. So out of Saturn's currently known 146 moons, at least 122 of them are beyond Iapetus. These irregular moons are apparent when their orbits are visible, because they heavily contrast the orbit of regular moons, which are all located from Iapetus inwards. The regular moons have neat orbits that are right next to each other. In contrast to those neat orbits, the moons beyond Iapetus have chaotic, typically heavily inclined orbits that are also very elongated. That is because they are irregular moons, meaning they are captured. Interestingly, there is also a massive gap between regular and irregular moons. Although Iapetus orbits at a distance of 3.5 million kilometers away from Saturn, the moon that comes right after Iapetus is S2019 S1, which orbits at an average distance of 11.2 million kilometers. This is overall the closest known irregular moon of Saturn. It is also a very typical irregular moon. However, this massive gap between irregular and regular moons could be because no moons are found at the moment at that location, and that could change. Saturn's 122 irregular moons have an average size of about 5.6 kilometers. Also, out of those 122 irregular moons, only 22 of them have prograde orbits. The 22 irregular prograde moons are divided into the Inuit group, which has 13 prograde moons, and the Gallic group, which has 7 prograde moons. They are divided mostly based on how much their orbits are inclined relative to Saturn. There is also a third group, which contains just 2 outlier prograde moons. The Inuit group of moons is especially interesting because it appears that they all have a light red color on their surfaces, and some of them are quite a bit more red than others. Still, because of the similar overall color, they possibly share a common origin. Maybe they are a result of an impact on one object. That impact sent the red chunks of surface flying that then got captured into orbit. Also, the Inuit group has the second largest irregular moon of Saturn, which is Sjarnak. It is very much an outlier in terms of size, considering that it has a diameter of 39 kilometers. Still, that size isn't all that great when compared to the largest irregular moon of Saturn, which is Phoebe. Phoebe, at its longest, has a diameter that is close to 220 kilometers. Although huge when compared to Sjarnak, it is tiny when compared to the moon, and especially Earth. Now, this moon isn't exactly obscure when compared to all of the irregular moons previously mentioned. However, it is worth talking about while on the subject of obscure moons of Saturn in order to better understand their context. What gives Phoebe its iconic look is its crater Jason, which, with a diameter of 100 kilometers, is close to half the diameter of the moon itself. Phoebe also has countless craters over 10 kilometers in diameter. So maybe Phoebe spawned new moons around Saturn. With the amount and size of so many craters, it is possible that when the chunks of surface were sent flying during impacts, those chunks were then captured into orbit around Saturn. Particularly, maybe 2 small moons which are right next to Phoebe are those chunks. They have a similar orbital inclination to Phoebe. Phoebe is very unusual for a moon of Saturn. It has a density of 1.6 grams per centimeters cubic. Now, that density is very similar to the density of Enceladus, Dione, and Titan, but all three of those moons are major spherical moons of Saturn. However, when we look at Saturn's small, non-major, regular moons, they all have very low densities. For example, Hyperion. It is a non-major, regular moon of Saturn. Although it is quite a bit larger than Phoebe, it is also significantly less massive. That is because it has a density of only about 0.5 grams per centimeters cubic, way less than that of water. And this density is very similar for nearly all, if not all other small, non-major regular moons of Saturn, of which most are pretty obscure and they will be talked about later. So the low density indicates that these obscure regular moons are very porous. So essentially they are piles of rubble that are held together by gravity. Likely that rubble is a mix of mostly water ice chunks with some rock. Phoebe, on the other hand, has a density of 1.6 grams per centimeters cubic, which means that it is not a pile of rubble, but rather a solid chunk that is composed of water ice and rock in approximately equal proportions volume-wise. Obviously, Phoebe's orbital characteristics alone tell us that this is a captured moon. It has a heavily inclined retrograde orbit that is also somewhat elongated. However, its composition further solidifies this claim, considering just how different it is to other regular small moons of Saturn. Potentially, Phoebe comes from the Kuiper belt or beyond, so from a place which is significantly more distant from the Sun than Saturn. Also, the Kuiper belt is where Pluto is located. Phoebe is the most likely reason Saturn has its outermost ring called, well, the Phoebe ring. It is located at an orbital distance around Saturn of about 12 million kilometers, which is also where Phoebe is. The way the ring material got to be there is potentially through impacts on Phoebe ejecting material into space, which is then captured into orbit. However, despite this ring being impressively large, it is also pretty much invisible in visible wavelengths. It was discovered in 2009 using the Space Infrared Telescope. Although Phoebe is a solid chunk overall, its surface in particular doesn't appear to be so solid. Rather, it is likely coated in a layer of fine-grained soil called regolith. That regolith also appears to be darker than the solid surface it sits on. That's why in so many craters, especially on the slopes, there are bright patches. That is likely exposed solid bedrock that is also quite icy. When objects strike Phoebe, they likely send huge amounts of the dark regolith flying into space. Interestingly, the Phoebe ring is also potentially the reason Iapetus has contrasting sides. As Iapetus was orbiting around Saturn, one side of it picked up a significant amount of the dark material from the Phoebe ring. That side then started getting even darker because the low reflectivity of the area means that the surface there was absorbing more heat, thus causing water ice to sublimate and leave the dark-coated area even more dark. One reason as to why Iapetus is so prone to having its water ice sublimate when just a bit of dark material is sprinkled onto its surface is quite possibly due to the fact that Iapetus needs nearly 80 days to rotate around itself. That means that one of its sides experiences 40 days of constant sunlight, which leads to relatively high temperatures, which then causes water ice to sublimate if there is even just a bit of dark material. All real images in this video of Saturn's moons come from NASA's Cassini spacecraft, which arrived in 2004 in Saturn's system. So this spacecraft did take this amazing photo of Phoebe. However, this is also Saturn's most distant moon, which was imaged up close. Most of Saturn's moons from Iapetus inwards were imaged up close, and most of them are not well known. However, Hyperion is not one of those moons. This one is, comparatively speaking, well known. Hyperion is located between Iapetus and Titan. Then going closer to Saturn, so going inwards, we encounter Titan, then Rhea, and then Dione. Right where Dione is, there are also two other much smaller moons, that is Polydeuces and Helene, that share nearly the exact same orbital distance from Saturn, which is 377,000 kilometers away from the center of Saturn. Because of that, these two moons are considered to be Trojans of Dione. Polydeuces is a moon that wasn't imaged very well. It is a tiny object. At its longest, it only has a diameter of 3.5 kilometers. So due to its small size, Cassini wasn't able to determine its gravity, as it was far too weak for Cassini to register. Because of that, we also don't know the mass and density of Polydeuces. However, it is very likely very similar to other small, non-major moons of Saturn, meaning it is likely a rubble pile moon. Helene is another Trojan of Dione, meaning they share nearly the same orbit. This moon is quite a bit bigger than Polydeuces. At its longest, it has a diameter of 45 kilometers. This moon has a surface gravity of only 0.0027 meters per second square at its poles. For some comparison, even the surface gravity of the moon is 1.6 meters per second square. Helene shows signs of geological activity. What we are looking at here is the side of the moon that is always facing Saturn, and this side has obvious flow patterns going down slopes. These flow patterns and sliding is somewhat unusual for such a small moon. The flow patterns and the reflectivity of the surface also indicate that the surface of this moon is coated in likely extremely fine-grained soil that is almost like a powder. Another interesting thing is that this side with these flow patterns has a lot less craters compared to the other side, which is always facing away from Saturn. The difference is quite large in terms of crater count. This moon is a very loosely held together rubble pile. Its density is only 0.3 grams per centimeters cubic, quite a bit less than even the density of Hyperion. Then going from Dione inwards, we encounter Calypso and Telesto, which are both Trojans of Tethys, another major round moon of Saturn. So all three of these objects share nearly the same orbital distance from the center of Saturn. That is a distance of 295,000 kilometers. Calypso and Telesto are also similar in size. Calypso has a mean diameter of 19 kilometers, although it is very elongated. Telesto has a mean diameter of 24 kilometers. Both of these moons are very reflective, quite possibly in large part due to the E-ring which the major moon Enceladus produces during its cryovolcanic activity. The water ice particles that make up the E-ring then coat the surfaces of these two moons with water ice. They are also both very likely rubble pile moons, and they very likely have surface with fine-grained soil. In this very regular image of Telesto, we can see its very smooth side. Replacing it with the false color image that used different wavelengths subtly reveals the color differences. Possibly the differences are there due to the difference in the size of grains. Going closer to Saturn, after Calypso, Telesto, and Tethys, and also after another major moon Enceladus, there are three moons that are sandwiched between Enceladus outwards and by a major moon Mimas inwards. Those moons are Pallini, Anthe, and Methone. They are quite similar in size, and none of them from any side have a diameter greater than 4.4 kilometers. They also weren't imaged very well, especially Anthe, but Pallini and Methone were photographed just well enough to confirm that they don't have very irregular shapes and battered surfaces. In this photo of Pallini, we can see its shape and smooth appearance. Along with that, we can also see Saturn shine. That is the day side of Saturn reflecting the sunlight onto the night side of this moon. Out of all three, we have the highest quality photos of Methone. It is incredibly smooth. This suggests that it is a rubble pile, but likely it is even more loosely held together compared to most other rubble pile moons. This is why it appears to entirely lack craters. The very loosely held together surface quickly erases them. Pallini and Anthe are also very likely rubble pile moons. Also, both Pallini and Anthe are the source of two different rings of Saturn. Basically, as meteorites hit their surfaces, they also eject the surface dust into space, which then gets captured into orbit. Pallini is the source of the Pallini ring, and Anthe is the source of a partial ring called the Anthe ring arc. Going closer to Saturn, we encounter Mimas, the smallest known object that is round due to its gravity. Despite that, it is still huge compared to every single obscure moon that is talked about in this video. That is why Mimas influences the orbit of Pallini, Anthe, and Methone in such a way that they vary a bit over time in their distance to Saturn. Then going from Mimas inwards, we won't encounter any major moons, as Mimas is the closest major moon to Saturn. After Mimas, slightly more inwards, there is Aegean, the second smallest moon of Saturn currently found, with a mean diameter of just 600 meters. Unsurprisingly, this moon wasn't imaged very well. However, what is somewhat surprising is that compared to other regular moons, it is much less reflective. In this image we can see this tiny moon in the G ring. Possibly it contributes quite a bit of material to this ring. Next, after Aegean, going inwards, comes Janus and Epimetheus. Both are mentioned at the same time because they pretty much occupy the same orbital distance from Saturn, which is 151,000 kilometers away from Saturn's center. In fact, the mean orbital distance to Saturn from both of these moons differs by only 50 kilometers. However, both of these moons have a larger radius than that gap. Janus has a mean diameter of 178 kilometers, so a radius of 89 kilometers, and Epimetheus has a mean diameter of 117 kilometers, so a mean radius of 58 kilometers. With that in mind, it then seems weird that these two moons never crash into each other, considering that their mean orbital distance to Saturn only differs by 50 kilometers. Well, what happens is that because of their very unique orbital characteristics, they never get closer than about 15,000 kilometers away from each other. And on top of that, they also exchange their orbits due to the gravitational effects these two exert on each other. So about every 4 years, a swap happens where one moon is closer to Saturn than the other. After Janus and Epimetheus, going inwards, we encounter Pandora. It has a mean diameter of 80 kilometers. This moon is clearly coated with fine-grained soil. That's why so many of its craters appear to be shallow. They are largely filled in. And from this angle we can see its different side, which shows two relatively large craters that also appear to be filling in, which is why they look so smooth. After Pandora comes Prometheus, an extremely elongated moon. At its longest, it is 137 kilometers across, while at its shortest, just 56 kilometers. In this image we can see this moon pulling the material that is present in the F ring. And in this photo we can see clear twists that Prometheus creates in the F ring. In this image, the night side of Prometheus is well illuminated because the day side of Saturn is reflecting the sunlight onto the night side of this moon. After Prometheus come three moons that are somewhat well known. I'm talking about Atlas, Daphnis, and Pan. All three of them also created some gaps in the rings. All three of them also have ridges on their equators from pulling the material off of rings onto their surfaces. Pan has a mean diameter of 27 kilometers, and it is also the closest moon of the three. However, it is still not the closest moon to Saturn. Currently, the closest known moon is S2009 S1. In this image, we can see that unlike Atlas, Daphnis, and Pan, which created gaps in the ring, this moon is a part of the ring. It also casts a shadow on the ring. It is also the smallest known moon of Saturn, with a diameter of only about 300 meters. Still, this moon does put into question as to what should even be considered to be a moon. After all, Saturn's disk is made up of water ice chunks, and some of them can be several tens of meters across. Should those chunks also be considered moons? If so, then Saturn has much more than just 146 moons. So every well-photographed but obscure moon of Saturn was covered in this video. Besides those, the irregular and distant ones were also covered. And the only thing we really know about those distant irregular ones is their orbital characteristics, general size, and reflectivity. They weren't imaged very well, and they likely won't be photographed up close for at least a very long time.